I'm Andy Fynn. I was the Babcock, or I'm still the Babcock CEM for the S&T part of the Grand Central Belfast Transport Hub project and the NIROC project. So I'm going to talk to you today about the S&T bit initially, and then we'll hand over to Con and Ryan, who will do their own sections and introduce themselves as we go through. Just a point, obviously that's a picture of Grand Central Station for those who know it. So I've used Grand Central Station here in the title, as that's what most people will be familiar with, but you will see it referred to as Belfast Transport Hub, or BTH, at some points in the presentation. That's how it started, as BTH. That's what it is in our contract, and therefore there's been a bit of an interchange, I suppose, in terms through the life of the project. NIROC was a separate contract, but very codependent, and you'll see that as we go through the presentation. So, all right, just a bit of orientation for those who maybe don't know Belfast. I've used this older Google map extract. The new one, if you look at it now, has got the new station on, but it shows the existing station, Great Victoria Street. I'll just try and get the pointer up here, and the new station that's being built alongside it. The main thing about this slide is really to get you some orientation. Both the old and the new stations are connected to the rest of the railway network via this triangle of junctions to the south: Westlink Junction, City Junction and Central Junction, and then they connect to the Dublin lines to the south and obviously to Dublin, and then going east via this central lines to Lanyon Place Station. Lanyon Place is the home of Belfast Central Signal Box and the new NIROC facility. And then from there we head north to Coleraine and beyond, and east to Bangor and Larne. So hopefully that'll get you the orientation of where the project's epicentre is. But just to, although the main centre of gravity of the project is obviously around the new station and that triangle of junctions that we just talked about, from an S&T point of view, we had work as far south as the interface to Portadown signal box at the fringe at Hilden, and also up to Lagan Junction just beyond Lanyon Place. So that gives you an idea of the footprint of the project as a whole. And on to some of the drivers for the S&T side of the project. This is a picture of the old Great Victoria Street station. As you can see, quite narrow platforms, compact site, curved, always busy as far as I ever remember it. And the signalling plan at the top just shows that there was quite a lot of operational flexibility for TransLink, in that all platforms could serve both the central lines via this Blythefield curve here and the Dublin lines. So you could access all platforms from all directions. A similar layout here for Grand Central Station. So when the development was done for Grand Central, 8 platforms was identified as being required. That was principally because the transfer of the enterprise service, which is the cross-border express service between Dublin and Belfast, was transferring here from Lanyon Place. So there are 4 long platforms that accommodate those services, but there was also expected to be a growth in frequency of services, more 6-car services, and all of that culminated in 8 platforms being the required outcome. So there wasn't enough room between the new station and Westlink Junction to be able to provide that flexibility of getting access to all platforms from both lines, and just physically not enough room to get the S&C in. So the 2 western platforms, 7 and 8, these 2 long platforms here, they're only accessible from the Dublin line. The other point to note is that we've also introduced a new, what's colloquially known as the third line, as another entrance into the station area. It's properly called the Down Dublin Reversible, but a little bit more on that on the next slide. So the third line was originally meant to go as far as Adelaide Depot to provide that extra capacity for TransLink. In the development, that line got truncated back to a connection point between Westlink Junction and Central Junction. So this turnout at 778 provides that facility to go onto the new line. That had some ramifications we'll touch on again in the next couple of slides. And the only other thing I want to point out is that we do have, because the differences in platform length and the differences in stock, the signalling interlocking does have line street controls which prevent us putting trains too long into the short platforms. Because the enterprise services were transferring from Lanyon Place to Grand Central, they used to use this down central curve to transition from the Dublin lines to the central and then onto Lanyon Place. With those services being transferred, Translink realised that the only real movements in future were going to be empty coaching stock movements to Adelaide Depot. So they took the opportunity to rationalise the central lines. So it's now a single line. That single line is reversible, and that allowed them to do away with this fixed diamond that they had between the central and Blythefield curves, which was a maintenance liability for them. That did give us, to access platforms 5 and 6 from the central lines, the other way around, to access central lines from platforms 5 and 6, we also had to make the up Blythefield a reversible line and introduce 791 points, which allows services to then come down the up Blythefield in a reverse operation, and then they transition to right road working through 791 points. As I said just slightly earlier, the third line was truncated at 778 points rather than go through to Adelaide. And the modelling at that time indicated that that would mean in some circumstances that services would be running into the station of the triangle area on yellow signals. So to mitigate that, an extra signal section was introduced into the Adelaide interlocking. So basically CL149 signal was introduced, a new CL149. And this section became a 4-aspect signalling with these 6 new structures. 3 of these structures we were able to install in advance, but the last 3 we couldn't install to the final week of the blockade and the commissioning itself, because we were running trains in this section up until that point. Another novel aspect for Translink is lockout devices in the station area. So each platform bay area has an associated lockout device. This one, as you can see, is for the platform 4 and 5 area. Although they have lockout devices in Translink, they don't have them for this kind of facility for servicing of trains and maintenance access. So they're provided in the station area. And another slightly novel introduction to Translink is CDNRA closed down right away functions on the platforms. So Translink have occasions when they have empty coaching stock to get to Adelaide Depot, which are not necessarily guarded. And in those instances, they have the facility to use CDNRA to dispatch those services. However, normal services are dispatched using train ready to start plungers, off indicators, and that functionalities exist in a number of Translink stations. So that's not novel to them. Just a brief touch on design. Design work actually for us started late in 2017 when we were asked to undertake a period of early contractor involvement for the hub. At that point, the station design was underway, and also the PWI design was well developed. So at that point, we engaged with both the designers of those two and Translink, and we produced from that point all the detailed design for the S&T elements for Belfast Hub. We did the preliminary and the detailed design for NIROC, and that included all the surveys, topo, geotechnical surveys, as well as the civil engineering for the S&T purposes, the signalling, electrical and telecom design. The station designs were coordinated, I should probably say the station area rather than just the station, were coordinated with a federated model and a common BIM environment that we all used and inputted to. And that was done for, that was used for clash detection and green positioning, etc. And we made over 400 design submissions, 90% of those approved first time. One of the aspects of that design process is we needed to agree signal sighting with Translink fairly early on, and certainly well before the new station was constructed. So although we had the federated model from the BIM tool for that purpose, we found that it wasn't quite powerful enough to use for formal signal sighting. So we engaged True North, who took that model and created these images you can see using their TrueSight signal sighting tool. So the image on the left is some signal sighting for one of the platforms, and you can see with the kind of quality of the federated model that was produced. And the one on the right is some beam analysis of the signal showing its the delivery of signal down the platform. So quite a powerful tool. That was quite a successful part of the design process. So NIROC, when we started the project, rail control in Northern Ireland was from 3 sites. So I had Coleraine Signal Control Centre here in the north, Belfast Signal Box Control Area in yellow here in the centre, and then to the south and down to the border, Portadown Signal Box covers that. Translink have a strategy to rationalise that signalling control into one Northern Ireland Rail Operating Centre, which is located at Lanyon Place in Belfast. Because of the extent of the work required for the Grand Central Belfast Hub project, they accelerated phase 1A of that project, so that's the first workstation, so that it coincided with the Belfast Hub project. So this small but busy area here in this image is the area now controlled from the Grand Central workstation at NIROC. So there are four control points at the moment. Just going back to the slide earlier, the yellow is the Adelaide and Dunbury recontrolled interlocking areas, and the blue is the area controlled by the new Grand Central interlocking. So the combined blue and yellow is the area of control of that new Grand Central interlocking. NIROC itself was constructed by Translink. They repurposed office space that they had in Lanyon Place Station, and they used that to co-locate their rail information controllers and signalers in the same area. Previously, they'd been dispersed at various sites, so this gave them for the first time that opportunity to co-locate everybody. So that facility provides also management, incident control, supervisory areas, messing, and equipment rooms for all the signaling and control equipment. This top image is an image of the control office area. Top left here, you have the new Grand Central workstation, supervisor's workstation, and just behind here, there's a desk which has been put in as passive provision for the next phase. And the bottom here is the Grand Central workstation as it was when we were in test mode. So we, along with Translink, chose Siemens to be the control system provider. They were our subcontractor for the project. So it's a Siemens WestCAD product that we use. So we have the control and display system at the heart of that, and that provides a signal workstation and a supervisor workstation, as you just seen from those photographs. They're connected out to relay interlocking interfaces at Grand Central, Adelaide and Dunbury via the new telecom network. The system also has a train describer system, which provides usual staff information on various terminals spread throughout the area. We also provide from their train routing information and train progress information to Translink's customer information and enterprise systems such as crew management, etc. And we get back from those systems timetable information to enable the dynamic route setting system to provide a level of automation to the signalers for train routing. And finally here we have the hindsight system, which is a login and playback system, and also provides a technician terminal facility, and that allows any incidents or things that Translink want to view on a playback system that gives real-time playback, just like you would see on a signaler's workstation. And finally, we provided a training simulator at Adelaide as a trainer and a trainee workstation. And we provided train-the-trainer facilities to TransLink, who then took on the training of a substantial number of signallers for the new NIROC facility. So that's that training facilities at Adelaide Depot. The heart of the signalling element of the project, I guess, is the new interlocking for Grand Central. This replaces the original Great Victoria Street one. TransLink opted to retain route relay technology for this project. And this interlocking has over 1,400 relays, 110 routes, and certainly the largest interlocking I've ever been involved in, the largest one Babcock have ever done. Due to the size of the space needed for the equipment, and particularly the relays, we needed a fairly large relay room. So this relay room is 15 meters by 5. It was fabricated for us by Tyrone over in Northern Ireland, and delivered to site in two halves. As you can see, there's the first half on the slab, second half being lifted in, and then Tyrone finished fabricating that on site. So quite a beast. Because we had to have it produced in two halves, we weren't able to do what we would normally do and build this and test it off-site in a factory. So after we had finished fitting out the relay room, wiring it up, we installed a test desk, which was provided to us by Siemens under the contract. I think this palletized furniture is by somebody else, but probably one of the testers. But we also designed some test desks to mimic the outside world. So these are these lovely stainless steel cases here that were produced for us by Rival to do that purpose. And if anybody wants a test desk, please put it in the chat, because we've got these on a shelf. I'm not quite sure what to do with them, but they served a very valuable purpose at the time. The signalling solution out on line side is fairly conventional and matches what TransLink already have in terms of their asset base. So HW 2000 point machines, LED colour light signals and routers, DC track circuits throughout, AWS, TPWS, LODs we talked about. We needed 28 new signalling locations, and we amended 19 existing ones too. New event logging and RCM systems, as well as modifications to existing, and lots of wiring modifications of various existing sites. This cantilevered signal here, 505 is coming into the station. It shows you the complexity of routes available from that signal into the station. For the telecom solution, it's based around 4 core nodes. So we've got NIROC, Adelaide, Dunbury, and Grand Central. It's a 10 gigabit core network over new fibre cabling, mostly new fibre cabling. We did also use some TransLink existing, based on Cisco routers and switches. 1 gigabit access rings to pick up telephony and signalling circuits, and the voice solution for the signaler is a Cisco unified call manager with IP trade turret HMIs for the signaler to use. Fairly conventional in terms of being very similar to a network rail solution. From an electrical point of view, we replaced the whole of the signalling power supply between Dunbury and Lagan Junction, so it's probably about 6 to 7 miles worth of railway. 2 new DNOs, one at Grand Central, one at NIROC. Each of them had their own interesting lives in being delivered by Northern Ireland Electricity, but won't go into that here. Very similar layout and topology at each site, DNOs into kiosks, and then 2 new principal supply points that provide 72 hours of supported supply in the event of failure of the DNO. The blue here represents 230 volt supplies. Brown is 650 volt signalling feeder supplies. So that feeds all of the new and the existing assets in that area. The power supply at NIROC is sized for the whole of NIROC's proposed control area, so there's no need to increase that for future parts of the project. And lastly, we've got because of the importance of NIROC, we also take another supply from a protected source at Lanyon Place to give another backup in the event of anything going wrong with the PSP. There's no electrification on the scheme, but we have done some passive provision in terms of clearances using AC immune equipment and circuits, and earthing's all to electrification standard. Just in terms of the construction sequence for the S&T, so we built out, we had to avoid originally the station area because obviously that was in construction and almost in construction right until commissioning. We had to avoid the triangle area because that was being rebuilt in the proposed blockade, which we'll touch on later. So we built out from the new relay room and PSP, where the DNO intake was, out initially down the Dunmurry lines. These slides are going to look like it was sequential, but there was overlap between them. So we built out from, as I said, down towards Dunmurry. Once we had the DNO connection in place, we were then able to transfer power over from the old to the new in October 2023, which meant that all this new equipment and the existing equipment was on final power supplies for testing purposes. And then we carried on building that into about March 24. Then we moved on, then it's not quite sequential, but we moved on to the central lines, building down towards the fringe at Botanic. Very similar situation in terms of the order in which work was done. And we commissioned that power-wise in February 2024. And then that was an earlier handover of the power assets to Translink at that point. Then we built the NIROC elements. The DNO for NIROC ended up being quite late, so that power changeover wasn't done until March 24. And this picture here is one of my kind of favourite pictures. When we turned off the power to Belfast Central signal box under a non-disruptive Saturday night possession, obviously everything went out, all the lights went out, which we expected. The question was, would they come back on again? So quite a bit of finger crossing, but spoiler alert, they did. And finally, we got the station available to us over graduated handovers between about February and May 2024. Blockade started in May 2024. So finished off in the station area. From an S&T point of view, we were ready for the blockade and all the PWI work in the triangle area. And now I'm going to hand you over to Connor and Ryan for their part of the project.
Thanks, Andy. 2 seconds, I will share my part of this. So sorry again. Thanks for that, Andy. Just a quick introduction then from myself. My name's Connor Fitzpatrick. I started working on the Belfast Hub project around the end of 2023 as a senior project engineer. Helped deliver and plan the PWI works from that point onwards through to completion. And then there was a small time where I carried out the track CRE role just post-delivery. So moving on to the schedule on my slides, I'll go a quick timeline back to early stages through to construction, just to give you an idea of the timescales involved. Moving on to site overview, quite a substantial bit in the delivery stages, and then a bit more detail, kind of engineering aspect of the Blyfield curve panel build and some of the plant and logistics of the project. So advanced timeline, going back, this is more PWI specific. I think S&T was well before this, and originally the PWI aspect was in the main contractor scope and then came out of it. So May 2020, Babcock started to develop a detailed delivery strategy, integrating it with the S&T programme. Moving on in October of the same year, collaboration with the main civils contractor at that point, both the PWI and S&T programmes. And then on to September 2021, which was the commencement of the enabling works. Now, more specifically, the delivery schedule for the PWI. There was some advanced prep works for PWI and civils back in early 2023, before kind of breaking ground on the PWI aspect in August 2023, which was the brownfield site, which is essentially the non-operational railway. So that commenced in August, ran up to around the December of 23, running into the first disruptive in the Easter 2024, followed by the main works essentially from May to August in 2024, and then into commissioning in autumn. So I know Andy's touched on it. I am more from S&T perspective, but I thought it'd be good to mention the old Great Victoria Street. From a PWI aspect, it with the curved platforms and jointed track. There was a lot of maintenance involved and maintaining the X and Y values, etc., for the platform clearances. And then the other notable difference was it increased to 8 platforms in the new station, just to facilitate the increase in frequency of the Dublin trains, etc. So, just to give you a quick site overview, regards to the PWI works, you can see there for the Easter blockade stages, someone. Stages CE and I was the part of the Easter blockade. Stage N and O for the summer blockade. And then part 2, sorry, and then you can see the other colours there for the part 1 of the summer and the brownfield site on the right hand side. There was 3 compounds there. You can see the East Ramp compound, which is in between essentially the old station and the new station. The BMX compound at the top, and Weaver's compound, which was primarily for rail. So you can see that the access is focused around that one area, with no direct access to the central reverse and down towards that area in the pink there. So we'll touch on that later, but it was one of the challenges. So starting off with the brownfield site, this is how we took over the site from FSGV. So they actually carried out the formation works within the station area, working out towards the Busway Bridge, and they installed the drainage. So it was ready for us to come in and start stoning up and building the track system. So the platforms in the throat area was completed between August and December 2023, as I mentioned earlier, whilst the GVS station was still fully operational. We can see we removed substantial work from the main summer blockade, which eased pressure and reduced disruption to the public. It's worth noting, obviously, huge amount of integration involved with the main civils contractor at this point, who are carrying out works on the actual platforms themselves, and managing that day to day. When we were looking to build in certain platforms, they couldn't be working on the platform. Just giving you another view here now. So this is looking back towards the new station, as the build progresses through what they call the Busway Bridge there that was above. You can see there just on the right hand side, you've still got fully operational Great Victoria Street, and in between was their kind of only access route. So when I refer to the East Ramp compound, that was that area there in between the works ongoing and the old station. As you can see, a very tight access road had to be managed, kept clear at all times to allow for delivery and plant. And it just shows you how restricted the site was, that it was all serviced from that compound there on the right hand side. Now, I've just swiveled 180 degrees essentially, and you're now looking out from the station and the bridge out towards the existing infrastructure. Now, the idea of the brownfield site was to get as much work done up to the existing boundary fence as possible, maximising that kind of window of opportunity. And you can see there, just in the top of the screen between the train and the road, there's a foundation slab in there, which Ryan will talk about later. But again, maximising the window and getting some of the slab done prior to the summer blockade. That took us into our first disruptive, which in essence was a trial run for us. It included 170 metres of track renewal and formation works on the up Dublin, and similar meterage on the down Dublin. And then, quite importantly, as Andy touched on, the installation of 778 points, which was the beginning of the installation of this new third line, which took you into platforms 7 and 8. The Easter blockade, as it says, it was an opportunity for us to carry out some time motion surveys, firm up and confirm timings for methodology in the summer blockade, and assess the effectiveness of compounds that we plan to use in the summer as well. So the next stage was into the summer blockade. Thought I'd just put this photo at the start, just give you an overview of the kind of the scale of the project, and we were working on multiple fronts at once. So key objective for part one was essentially to tie in the new Dublin and Blyfield lines into the new station. Upon mobilising for this part, we removed the existing railway boundary fence and began lifting the track out, including the Great Victoria Street, which you can see there now on the top left. And it's worth noting that during part one, the central lines remained open. That was allowing the Dublin Enterprise Service to continue operating via Lanyon. And I've just shown the physical barrier there that was in place for the duration. Carrying on, I will touch on this, but again, Ryan's going to go into the more engineering detail, but I just thought it's relevant in terms of the P-way. Huge part of the summer blockade was the completion of the foundation slab. Now that forms part of the formation design. Installation of the slab was critical activity in delivery of the summer block. Essentially, any delay to this would have pushed back the subsequent installation of the track. And just a wee note there, regards to the brownfield sites behind you, essence of this picture, the Blyfield and the Dublins above, it cut it off, so we had to create an access road there on the left-hand side of the picture. Moving into the Dublin lines, we referred to this as Stage M. Included the following work, so formation build-up across the three lines. Now there was layers 6F, Type 1 and Teram, and you can see there the crossfalls falling to the cess. There was a transition in this where it went to a deeper design, so there was a transition ramp within the formation. Those and bottom ballast levels, and for this stage installing 800 metres of plain line and a crossover. Just putting a wee point in here regards to the access point fell in the middle of the job for this stage, so essentially we're always working back towards the station, which we tried to avoid in renewals. You normally work from one end to the other, but we are working from both directions and essentially digging ourselves out of the footprint for each layer of the build-up, and then the ballast, and then the track install, which I believe you can see on the next photo. So on the right-hand side is the BMX compound that was servicing this area. You can see the 779 crossover in construction, and the three Dublin lines going down towards the station. And just some final photos to give you an idea on the left, compaction of the full ballast footprint, and then some post-tamping photos of the Dublin lines. That took us into stage P and Q, we were labelled, which was the Blyfield curve. Again, formation build-up, similar to the rest of the design, 6F, Type 1, Teram. Transitions between them into a deeper dig. This time we had 6-foot drainage to install, and those are the bottom ballast levels. And then this time we installed 45 number pre-curved and pre-built timber panels using McCulloch's. So a bit of different methodology due to the tight radius of the curve. I'm going to go into some more detail on how we managed that later on the slide. Again, just some more oversight, just the scale of the excavation there on the left-hand side. And then building up our layers of formation, carrying out the drainage at that time, which is optimal for installation, and then up to almost the finished product with the bottom ballast installed and our panels plated up and put in position, and that's actually before tamping, so really good quality. Moving on, it would refer to as closing the gap. Now, this is essentially the area above the slab. So by the start of June, Blyfield and the Dublins had been installed. The foundation slab was now complete, and the process of joining the new lines could commence. So A large area to stone up and doze. 7-point ends to install, including a double crossover. The associated plane line to connect this in, and some more drainage. You can see there now to the top of your screen would be the new station. So we're working out the double crossover through the help of McCulloch's. We're landed 783, 782 alpha switches. And you can see the third line on the far left progressing well out of the station. And now this is essentially there closing the gap. So if I take you from right to left, storing up and compaction of the Dublin lines, then installing the 3 plain line areas in the Dublin lines, and then over to the left you can see the Blyfield lines starting to be installed, which gave you this kind of finished article to this point. So that's us now. Top left, your Blyfield lines coming up, your Dublin lines, the next 3 all coming down, servicing platforms 1 to 8 on the Belfast Grand Central Station. At that point, it was on to part 2 of the blockade. We had 2 stages. Stage N was central reversible. So this involved reconfiguring the track layout. So there was 2 lines originally, and they were dropping this down to 1. Formation build-up again, the exact same. 6F Type 1 mixture of layers of Terram and Geogrid. 300 metres of new cess drainage that was to be installed once the old track was ripped out. Those in the bottom ballast, and plain line jointed track. So you can just see in the photo there that we're actually using the track on the left hand side. We left it in as far as reasonably possible before the new single line alignment overlapped it. That allowed us to run out the sleepers in that photo, and then use the McCulloch sleeper beam to run the sleepers into areas that there wasn't a service road. So you can see that there on the right hand side, sleepers laid down through the single line, and on the left prior to that you can see the formation build up, but also the alignment where it starts to shift over into where that other line was, and that was as far as we could rip out at that point. And just some post-tamping of the central reversible, now a single line with the cess drainage on the left hand side. That takes us into the kind of the final stage for this summer blockade. Again, stage O, so this is tying into the central reverse and the other side of the Blyfields, reconfiguring the track layout to facilitate the change to a single line, and the same formation build up and doors in the bottom ballast, and then this case installation of a 790 turnout and 791 Alpha Bravo. Again, more construction photos to give you an idea. Bottom ballast there, the boys installing the S&C bearers, and some more formation build up and drainage there. And just some final photos again. So on the left hand side, that's the 791 crossover, now looking back into tying into the existing infrastructure through its City Hospital station. On the right hand side, that is 790 turnout going into the previously just discussed central reversible, now single line, and the Blyfields on the right hand side. So that was the staging delivery. I just thought I'd dive into some more maybe engineering aspects. There was the Blyfield lines was pre-curved panel build, so the PWI design for the tight radius lines was confirmed as jointed track construction with an accompanying check rail arrangement. Posed a number of factors to consider before methodology or construction. One being the installation methodology. Would it be a loose build? Would it be panelised? Pre-cut rails, or keep lengths longer and cut to suit? Consideration of the check rail arrangements and the joints, consideration of design gauge variation. So due to the tight radius of the curve, there was gauge widening through the curve. Consideration of the track layout. So there was adjustment switch locations within the curve, differing IBJ types and locations, maintaining compliant rail lengths, and then taking into consideration the temperature of installation, etc., for joint gap measurements during install. So after much consideration, methodology we chose was to panelise the layout. So this involved ordering pre-curved rails and IBJs, a mixture of predetermined rail lengths and cut to suit to allow for some constructability tolerances was the final option that we went with. Essentially going back to first principles to establish our leads and lags, but using CAD to design each panel and ensure accuracy. We created a panel schedule, ensure correct order of construction and installation, and again we made use of McCulloch's panel lifters. That just allowed us to build both roads concurrently, working back towards our compound. So just a snippet from the CAD model, showing the panels there overlaid onto the existing PWI CAD file, so it was very accurate. And from this, we were then able to pull out these diagrams. So 45 of these in total for both roads, and essentially these were given to staff on the ground, and they were built off the critical path within the compound. It details the length of both rails, inside and outside, sleeper spacing, the gauge, if it changed or if it was constant, and the radius. And the pink writing there for the rails was how they came marked from factory, so that there was easy identification of them on site. And just some photos then of the kind of installation of them through the Blackfield curve, and a wee aerial shot there from the drone. Moving on to logistical challenges. Biggest challenge was essentially the location. You know, we're working in the heart of Belfast city centre. Key points: interfacing with the main works contractor within the station area, limited suitable access points and restricted sites, large volumes of material to be brought in and removed through compounds. So it's probably most of you are aware there's no engineering trains or large ones that you'd see in the mainland available to take material directly from site away to compounds, etc. So that then in turn leads to reduced productivity rates due to the distance travelled from site to access points, and the reduced capabilities of the methods we were using. So one of the solutions, we maximised plant that was available to help combat these challenges, which I'll touch on next. So these were 360-degree track dumpers. Due to the access constraints and the subsequent methodology, travelling over the formation couldn't be avoided. Therefore, the track dumpers, the perfect solution. They also are capable of swiveling 360 degrees, meaning there was never any requirement for them to turn on the formation, so they were always driving straight in and straight out. Second help was the Unimog with trailers from Dixon's down south and south of Ireland that come up, essentially close to an engineering train as you can get. Helped massively during part 2 when we were further away from our access points. Obviously, as well as being loaded with spoil, they're actually capable of side tipping like a conventional side tipper train in front of the dozer, and they could also drop onto themselves for stoning up, as you can see on the photos. And finally, we used GPS excavators. So with limited space and compounds, large volumes of material to remove, these allowed us to be as efficient as possible. The machine control files eliminated the chance of any over-digging or digging too wide, which essentially meant no excess spoil being removed. And we were also able to create drainage excavation files, which increased the production massively on the drainage routes. So essentially all that combined, it allowed us, if we were working on multiple fronts, to free up engineering resource, and it was a case of coming back and forth to validation checks. And just to finish up for me, that's just a kind of oversight of the metrics. Some pretty substantial quantities there, 19 units S&C, a lot of ballast, and a good point to note that there was a lot of ballast cleaned and recycled, and there was also a number of old timber bearers that went to for reuse and other purposes. So I think that's now me ready to pass on to Ryan, who's going to dive a bit deeper into the foundation slab.
Yeah, thanks for that, Connor. So, the final bit of today, I'm Ryan McCoy, and I'm presenting on the Transport Hub, as you all know. So, this is the project now nearing completion. Is the largest integrated transport hub in the island of Ireland, and it is the biggest railway interlocking constructed outside of London in the last 20 years. For this project, I was the civil CRE, which is a contractor responsible engineer, and the temporary works coordinator. So, the project was first talked about in 2012 and obviously due for completion later this year. The old facilities we've already touched on. They'd been operational for the last 29 years and had remained untouched from the day they were installed. They served their purpose, they were full capacity, and hence the call for the new hub. The new station, 8 platforms, 26 bus stand, and a state-of-the-art building catering for 20 million passengers per year. The new station has an increased capacity for up to 2,000 seats per hour for both rail and bus movements in and around the city and then obviously beyond. The image to the top right of the slide, that shows some of the key companies that made the project a success, obviously with the Transing at the top there. And then you can see from the picture in the centre of the slide where the station was actually positioned, right in the heart of Belfast city centre, a short walk from Belfast City Hall, strategically positioned between two universities and the two largest hospitals in Belfast. So the location of the site on its own presented its own challenges, I guess. The middle picture on the slide shows the construction of the site during the enabling works, with the picture to the right showing the old station demolished and the interim works to connect up the new station. So it gives you a bit of a contrast from the start and where we were in the interim period. I'm moving on then to the civil scope. So to protect the programme and reduce the overall risk profile to the basically to the delivery of the project, Civils completed most of their work on possession, work and rules of the route. So that basically means we work between the last train in the evening and the first train in the morning. We managed and delivered this work for almost 2 years prior to the station opening, working alongside various subcontractors and managing them to complete as much as they could, in advance of bigger blockades or other blockades that we had planned in. This it takes a lot of thought and consideration when the project spans for 7 miles, predominantly dual line track, and it passes through 8 different stations. So you need to consider your other disciplines, your possession arrangements, both your access for your plant and then your people as well to get to the work area. So we then, part of this project, I was the temporary works coordinator, and we had to look at managing temporary works on behalf of our subcontractors. So to the top right of your slide, you'll see a UTX design, which is an under track crossing. And basically, the temporary works that we had set up is just to the left hand side of that's that photo showing. So that's how we constructed that UTX piecemeal. And we approved that with our client Transing at the time, but it all takes your temporary works back to its first stages and ensuring that you can actually build what's on your design. And then the picture to the bottom right of the screen, actually Andy has shared that with you already, but a question, does everybody look at what's involved in terms of civils? Not many people pay attention to the drainage route there to your left hand side and the troughing route as well, which is obviously an intricate part of the railway system as a whole. So it's making sure that we all come together to make the system work. And then moving on to the foundation slab. So due to the widening of the rail corridor on the approach to the new station, we would pass over a section of land that contained Belfast Sleech. Now, not many people know what Belfast Sleech is, but it's basically a mixture of soft estuarine clays and silts, with a combination of peat mixed in through it. So its exact characteristics, they vary drastically, and they present difficult conditions to build on. It's considered one of the most problematic soils to work with in the UK, and in certain areas of Belfast it can have depths up to 8.5 metres, so that's why we has quite a substantial foundation slab, which I'll detail here in a wee minute. So therefore, with the volumes of traffic that we expected in this area, the solution needed to be one that would not require a large amount of maintenance in the future. So a reinforced concrete slab, not a track slab, I'll add for those that will know of it. It was a reinforced slab below the ballast, with depths up to 700 mil. The slab consisted of over 1,000 cube of concrete, and as shown in the design drawings, it would be poured below the traditional build-up of a railway line, so below your ballast. The design to the bottom left of the screen shows how the slab was split into 3 sections. It's worth noting at this stage that the track side, or the blockade element there to the bottom left, denoted in red I suppose, was underneath the existing entrance to GBS, so we couldn't work in this area until the old station was completely closed down. When Babcock was presented with the design, Transinc had already engaged, and they had looked at constructability of the slab. The design to the top right of the slide there shows a sheet pile design. It's quite extensive for the construction of the third line area. The design shows piles of 12 and 14 meters long, positioned 1.5 meters from the nearest running rail. So we looked at this, we reviewed the design, and we engaged with specialist subcontractors to pull together possible solutions to complete these works. I suppose it's worth noting at this stage that the logistics of the site and the positioning of where we are, you have a bus lane, which is operational just on the north side or the upper side of the screen to the third line area, and then you have an operational railway line below. So when we got our prices back as expected, they were excessive, and we needed to look at other avenues. From the onset, I always thought if we could have removed the need for sheet piling completely, this would have been the best possible method of construction. So we looked at, to the bottom right there, you'll see we have temporary works design. So we looked at this, and we basically came up with a solution where we build legato block wall. We consulted with temporary works designers, and we refined what was like my initial idea to basically build a legato block wall adjacent to where we would need the slab. This encroached on the track support zone. For those of you who don't know, this is the area that's below the track that's needed to maintain the integrity of the railway line. And when you encroach in that area, basically there's more stringent control measures that have to be adhered to. This, combined with the uncertainty of Belfast sleet in the area, meant that we were unable to use this method, and we were unable to then move these legato blocks any closer to the slab itself because we would encroach on the slab. So as a team, we were determined to come up with a viable solution to construct the slab, and we started looking at the phasing of the overall slab and the sequencing of it. So to mitigate against the extensive sheet piling, we looked at bringing the works into blockades, or a series of different blockades, with the first solution being to construct the third line area at Christmas time. This mitigated against extensive temporary works, which we've talked about, the sheet piling, etc., but it also maintained the integrity of the railway line. So during the construction of this, we would temporarily undermine the existing track. The blockade was a very short duration and required swift construction in the lead up. During the blockade. So in the lead up to the blockade, the subcontractor, they used their initiative as best they could. They prefabricated the reinforcement cages, so that they could be dropped into the excavation in sizable sections, and that's shown there to the bottom left of the screen. We also used ideas such as permaform, which is a permanent formwork. This helped to protect the program as well, and it saved time, as there was no time lost stripping and moving traditional shutters, and it also meant that whenever we set up our shutter initially, we were able to place 80% of the backfill around the concrete structure itself before we had even commenced pouring. We also then used the use of admixtures to accelerate the hardening of the concrete, and this also then allowed us to reinstate ballast over the top of the structure, to reinstate the track support zone and the ballast shoulder accordingly. The picture to the middle of the slide then shows a concrete pump, which we then used to ease the speed of pouring the slab itself. A machine such as this could only have been used on night shift possessions due to the location of the adjacent railway line or within a blockade. So it all facilitated and helped towards the overall build. Given the large area of the network that was closed down during this Christmas blockade, we also devised a plan to work with our subcontractors to take advantage of the closure. And that's what the pictures to the right of the slide show. So you see the sort of works there on a platform that was adjacent to us. And I suppose the key advantages of this was we had no interface with the public on the transport or on the platforms themselves, as the station and the route was all closed down. I guess as well then too, it allowed us to open up large sections of the platform, and we didn't have to do this piecemeal, so it was far more effective and a better use of our time. So the foundation slab then, following the Christmas works, we moved on and we continued the construction of a larger section, or as large a section as we could offline. So that's shown in the top left. Completing this, or as much of this before we then would move into the summer blockade. So we maximised the area of what we call the brownfield slab, and we implemented this via a CSE environment, which is ultimately bringing a high street environment. Means you can bring in traditional, skilled labour staff and that, and you're not combined by some of the rules that affect the railway line itself. So we done this, and we basically constructed as much on day shift as we could, adjacent the live railway line. And this basically, you have some additional control measures and things that you have to do for compliance and obviously with health and safety. But this meant that there was less work completed at night. Obviously, we're right in the heart of the city. It was the most ethical thing to do at the time. The picture to the bottom left of the screen sort of shows the CSE barrier and how we had this implemented on site. And it shows how we had the area of poured slab maximised on the non-track side of the CSE. During the planning stage, I had the location of the construction joints moved as well to accommodate this CSE area. And the aerial photo shows sort of the sawtooth arrangement of where the joints were then positioned on the left-hand side of the barrier as you're looking at it on the screen. We then sort of used a couple of smarter ideas, Ancon couplers, things like that, so that we basically didn't have to induce long lap lengths, so we could maximise the area that we could pour. Then moving on, as the temporary works coordinator for the project, part of my role was ensuring the temporary works for cranes and other platform designs. So I worked alongside Connor and some of the other PWI colleagues to position a crane to basically position the final S&C units on top of this slab. We worked alongside our temporary works designers and the permanent works designers to come up with a design for the crane, etc., to set it up on top of this slab. And then that allows us to position the S&C units direct to where they need to be. So, between us collectively, we minimised the overall work that needed to be done to build the PWI element of it. And then we move on to the final section, which I classify as the bottleneck. So the phasing and management of these works was no easy task. Trying to program and deliver the slab alongside the ancillary civils, drainage works, and whilst PWI pushed on, closing up the gap, as Connor would refer to it as. The sketch to the top of the slide shows the green area that we'd already poured, with the red area now remaining. So civils couldn't complete any more work until the old station was fully closed down. So with a large element of persuasion, Translink granted Babcock a 13-week blockade to close down the old station and link it up to the new network ultimately. A 13-week blockade, virtually unheard of in the network. However, given the complex nature of the project and meeting at this bottleneck, it was necessary for us to deliver. The pictures on the slide show some of the construction work that took place during the trackside element of the slab on the approach to the new station, and how it runs out to the intersection of the new Bangor line, the Portadown-Newry line, and the adjacent Dublin lines. Due to the available space on site and meeting at this pinch point, the first 5 weeks of the 13-week blockade was predominantly for the civils discipline to deliver the remaining elements of the foundation slab. So I was responsible for managing and ensuring that this work was delivered on time throughout this period, as you know, it would have a knock-on effect to the rest of the blockade and then the other disciplines as well. The unfortunate part for me is that all the hard work, planning and managing of this foundation slab, from the design stage right through to delivery, will remain largely unseen by all those who have benefited from the new infrastructure and services that have been provided as part of this project. However, without such a structure and constructed in the manner that it is today, I suppose the project wouldn't be in the position that it is today as the flagship project in Belfast. And then just a wee quick conclusion. Andy's already touched on NIROC itself, but Northern Ireland Railway Operating Centre. A large element of the team that worked on BTH also worked on NIROC, and it was, the two projects had to be managed together, and they were both working towards the same key milestones. And it was, the two projects that delivered on time. I suppose that's the key thing, and safely, I suppose, as well. And that completes my presentation today. So I'm going to hand back over to Andy then.
Hi there, Stuart back here. Well, Andy, Ryan, Connor, thank you very much for a really enlightening presentation, giving some of the engineering detail behind the fantastic project that you've been involved in. I haven't got any questions. We're slightly over time anyway, but I haven't got any questions as such. So I guess at this point then, all I'll do is just tell everybody that if you want to carry on the conversation or ask some questions after this point, we do have a dedicated LinkedIn page. So you are more than welcome to raise other questions, and we'll make sure that they're passed across to Ryan, Connor, Andy, depending on which discipline it is. I'd just like to remind everybody that the next session in 2 weeks' time is the adoption of geopolymer solutions to reduce the carbon footprint of rail maintenance projects. So tune in for that if you can. So I have nothing more to say than to wish you all a great rest of your afternoon. Thank you very much for joining us on Lunch and Learn, and hope to see you all again in the future. Thank you very much, everybody.
Thanks.